in space exploration, science, and astronomy. Today, we've been having all kinds of internet issues. We do have a backup if necessary. Please be patient with us.
Yeah. Basically, I've got my phone running StreamYard also, so it won't drop, but our image might go away. And so we should be able to wrap up most of it, except my screen sharing will be gone if the internet.
We may or may not be able to answer comments, reply to comments. Anyway, we're here on Friday nights at 9 p.m. Pacific time, 12 midnight Eastern time, and 2 p.m. on Saturday in Queensland, Australia. We are broadcasting live from Thousand Oaks, California. Thank you so much for joining us. Tonight's topic, Solar Jet Hunter. We'll be back in 8.3 seconds. Solar Jet Hunter is another citizen science project, so you can contribute. After the show about the stars and supernova on June 10th, this citizen science project caught Jeff's eye. Join the hunt for solar jets, enigmatic bursts of energy from our own star, the sun. Jeff, tell us about what you learned over on Zooniverse.
Sure. First off, hey Scott. And then let me get my screen going. Add to screen. And here we go. Okay, Solar Jet Hunter, another Zooniverse. This should look very familiar to you guys by now, but the about, classify, top, collect, recents. They have some relatively new data. I was a little bit concerned because of the one that blew up on me the one time. So I've been watching it. It started out at 78%, then it went to 79% done, then 80% done, and now it's, last time I checked, it's actually lower than 80% done. So it's gonna be going for a while. They are looking for solar jets, and the difference between a solar jet and a solar prominence is the solar prominence comes back, arcs back down, and the solar jet actually leaves the sun, and that they're looking for the jets. Oh, it's 79% complete now. And if you notice, not a small project, but it's been going good for a bit. And the Solar Dynamics Observatory spent more than a decade collecting data from the sun. While some progress has been made developing algorithms to identify jets, these programs are not accurate enough to provide the sound research data. A far more effective tool for finding interesting features on the sun is the human eye.
As usual.
Yeah. Now, the about has some pretty good stuff. Intro, NASA Space Weather, and spaceweather.com have stuff on the sun. NASA Sun, NASA Solar System, again, some decent links in here. NASA's Parker Solar Probe, and the ESA and NASA. Oh.
Hi, Cliff.
Hey, Cliff.
Welcome. Thanks for joining us.
Yeah. So, and these links to this Parker Solar Probe have some pretty interesting images and information on them. ESA, not much there. The ESA site kind of, it has some stuff on there. It just kind of, their website kind of reminds me of someone told them that they need to have a website, so they made a website.
Okay. Not all websites are useful.
Yeah. So ESA has a solar orbiter, and NASA has a solar orbiter website.
Is it the same solar orbiter?
Yes.
Okay. Same orbiter, different country
websites. Yeah. And got it. Maybe I'm just used to this look and feel. Maybe this is a European design for a website. don't care for it.
Okay.
But there you go. And they need a solar jet database because they're trying to figure out what's going on inside the sun, what causes it to make solar jets and stuff like that. So they need a bunch to look at.
Okay.
And they have a heliophysics event knowledge base right here. And this is actually a fairly interesting tool. And
Oh, cool.
helioviewer.org, this is the sun. And you can play around with this. None of this has anything to do with the project, but it was interesting to me, and they had links to them.
Yeah, it's always cool to have, like, additional material that you can learn from, and it just increases your understanding and enjoyment. Really.
Yeah. And so here's more stuff. This is the data. Every 12 seconds they make an image of the entire solar disk.
Wow.
In several ultraviolet wavelengths.
Okay, and it's always turning, right? We're always seeing a different part of the sun.
But
unlike the moon, which basically rotates at the same rate as we revolve around. Yeah, okay.
And every 12 seconds, for one thing, they want to catch as many events as they can, and so 12 seconds. And what they do is they pack a bunch of these 12-second images into a little mini movie.
Oh, neat.
Yeah.
Okay. Cool. Do you have some?
They do have some in the in here. So the team, this is their team. So
wow, big group.
Yeah.
Good. Lots of support.
Yeah. And of course along the side here,
they're all over. They're all over the world, I take it, or is it just U.S. and Europe?
U.S. and Europe. However, there are some Chinese people. I just don't know I don't know if she's Chinese or if her family's from China.
Okay.
So, graduate of the University of Minnesota. So, educated here.
Yeah, definitely.
In fact, a lot of these guys are University of Minnesota.
Oh, interesting.
At least for the Zooniverse project. And the results, this is jet or not. And you see, I was going to do a slideshow of this where I picked in, screenshots, but so much of this stuff has moving images, these mini movies, that I just felt that it would lose too much if I did a slideshow. So
okay, yeah, a live site is interesting too.
Yeah.
Cool.
So this is one of the data flows that we were supposed to be doing.
Now, is that a jet? Or
this is a jet.
Oh, it is.
You notice
it almost looks like it's coming back, but it's sort of an isometric angle or something.
Right. Yeah. Because this is the disc, and this is just off of the edge of that edge of the disc.
Right.
Instead of a top edge. Yeah. And so that was one of the data flows. They have a FAQ.
And that's FAQ, frequently asked questions, for those that didn't catch that. He said FAQ. Here they have a FAQ.
Yeah.
It's sort of lingo.
I'm a computer guy.
Well, any lingo you want to try and explain as well. I mean, it could be computers, it could be astronomy, space exploration, anything. I mean, ESA, European Space Agency, same idea. Spell it out a little bit more.
So what's a solar jet? What's the difference between a solar jet and a coronal jet?
Nice.
How do solar jets form? And as they say, it's not exactly known how they're formed. But in general, the difference between a prominence and a solar jet and a jet is that a prominence follows a magnetic field. The magnetic field
goes out and
extends
goes back, right?
Yeah. The magnetic field extends out past the surface of the sun, if you could actually say that it has a surface, because it doesn't really. But
beyond.
Yeah, it extends out past the surface. Yeah,
it's the chronosphere, right?
Yeah.
So just like other things, it has sort of layers of what's there. In fact, I think the layer that's just above is hotter than the
surface.
Surface.
Yeah. So It follows the magnetic line and just comes back down.
But the jet keeps going.
With a jet, they think that the solar line somehow twists enough to break and reset to a different location. That means that nothing's pulling it back down, so it just shoots out.
So how is that different from a coronal mass ejection or a CME, as they
My guess is that a jet is just a smaller version of the CME.
So a CME or coronal mass ejection is just big. And
it's a big jet.
It's actually kind of dangerous to us on the Earth.
Well,
things can be knocked out. Electrical systems can be knocked out. That kind of thing.
It's nothing evolved because there was no danger to us for all of the time that we evolved until we had an electrical grid.
Yeah.
You know.
Yeah.
Because the electrical
and we
grid,
haven't hardened them against this sort of thing either.
And the bigger the grid, the more danger there is because
the more vulnerable it is.
Okay. Yeah, because it acts like a big antenna. The bigger it is, the bigger the antenna, the more of the charge it gets. Cool. So yeah. So how do solar jets form? Essentially, they don't know exactly, but essentially what I said. Difference between solar jet and other features. Flares and coronal jet mass ejections also happen frequently in addition to jets. Jets have two main characteristics. They appear to be ejected out of the sun, and they are narrow features. Okay, so that's the main thing, is that the jets are squirting out of a small thing, whereas a coronal mass ejection is just poof.
Okay, so it's sort of size and diameter from the surface. Okay.
Yeah.
Cool.
Yeah. So it's almost like the jets are out of a nozzle.
Okay.
So why should we care about solar jets? Because for one thing, we're trying to learn about all stars, and we're studying the one that we can. It's right near us, and also whenever the sun. Oh.
Go ahead and finish. We have a comment. We'll flash it in just a second.
Well, as we mentioned before, the sun can cause damage to our solar grid and other things, our satellites and stuff. So the more we know about these, the more we know about the sun.
All right. So Cliff comes with, if we have another Carrington event, we will be stuffed.
Yes.
So Carrington, basically, I don't think I'm familiar with that one. Is that
it knocked out a bunch of
in the United States or somewhere else, or
in the Northeast?
Okay.
But we were very new to electricity at the time, so
okay.
Yeah.
Yeah, and I'm pretty sure there's ways to, I mean, when we send stuff out into space, we do what's called hardening. And these are, certainly electronics, electrical systems, that kind of thing. I mean, there's certainly ways to harden systems like that.
Yeah.
I don't know that we do them. Of course, it's, when you're talking about a satellite, you've got a small system to work with.
And it's not as big of an antenna.
Okay.
The longer the wire, the more juice it collects.
Okay.
The thing to do would be to break it up in a bunch of small pieces, and then have some isolator between them, and then some way of getting the electricity past the isolator.
Yeah, but you're going to have signal loss every single one.
Exactly. Okay. And more things to go wrong, more
equipment.
Yeah. And
more things that can break down.
Here's the thing. We, in the U.S. at least, and I don't know about other countries, in the western part of the U.S., we could actually do something like that. It would be expensive, and it would be a massive energy loss, but we could do it. Especially the Northeast of the U.S., and probably all of the east of the U.S., where they've had electricity a lot longer, everything is so interconnected and intermixed that there are areas like Michigan where they don't want to mess with it because they don't know where everything is, and they're afraid of blowing the entire Northeast.
Oh, because it wasn't like planned. It was sort of organically
developed. They had a bunch of separate things, a lot of them overlapping. They all merged into one, and they got it to work and really don't want to mess with it. Kind of like early Windows. There are parts of Windows that are from Windows 3.1. Still in there because it works. They don't want to mess with it.
Got it. All right. Scott comes in and he says, makes me wonder if there was an unusually high amount of solar jets, if that could cause some electrical
Yes.
problems or satellite problems like a CME would. Interesting. Good question.
Possibly, but they'd all have to be aimed right. Because for one
Same
thing,
with the coronal mass ejection. I mean,
right.
it could happen anywhere on the surface of the sun, and if it's not like directed at the Earth, it kind of just dissipates into space.
Or if the Earth isn't in the right orbit by the time it gets to our orbit.
Mm-hmm.
A jet is much narrower, for one thing, so it has a much smaller chance of hitting the Earth.
Okay.
Doesn't produce quite as much stuff, and if you had a bunch of them, they'd all have to be in a line, because of course a long jet would move past the Earth.
Okay.
So you'd have to have a bunch of them and basically machine gun the Earth. And I don't think that our understanding of the way the magnetic fields on the sun work would allow that to happen.
Okay. Yeah, that seems pretty unlikely. All right, Cliff comes in and he says people don't know that our sun is a star. Yes, it's the closest star. And people were getting a shock from telegraph lines in the Carrington event. Okay, yep. I didn't realize that.
Yep.
I'm not really familiar with the term Carrington event.
Well, because the
I know we've had grid issues, but
the telegraph lines were the longest power lines that we had at the time, and so those were the biggest antenna. Yeah, if it happens now, we're screwed, or at least that section is screwed. I mean,
okay.
If the Americas get hit, probably about a third of the U.S. and a good chunk of Canada are out. The rest of the world's going to be okay.
Yeah, I saw something. There were three main parts of the United States grid. I mean, that are interconnected, and it's sort of West Coast, East Coast, and then Texas was pictured there too. So
yeah, and that causes Texas some issues too. But you know, on the flip side, if the East Coast goes, Texas is okay. Is probably okay. If the West Coast goes, Texas is probably okay, unless the event overlaps Texas. Okay. Other countries are Europe. If Europe gets hit, it's a lot worse, just because all of those countries are fairly close together. I mean, if you think about it, Europe's about the size of the U.S.
And I don't know how their grids are.
Yeah, I don't know
if they work together. Because I know one of the things that happens here is if a small section goes down, some others can bring in power to. Well, they can bring in power, but if they overload, then like dominoes, they'll all fall down.
Well, if one section goes, it drops out of the grid. The grid tries to route the power around it, which puts more stress on the ones around it, which could knock those out. And that took out in the 76. That took out the entire Northeast.
Yeah. Well, no, that was
one relay, but that caused a cascade.
Okay, it wasn't a coronal mass ejection.
No,
because there have been other ones that created problems. I don't know a lot about it. That could be a whole show.
Yeah.
At some point.
Yeah. But the East Coast is just a mess with the power lines. I mean, really, you need to rip them all out, relay new ones. But no one's going to do that.
No one's willing to be without their refrigerator for that long, I suppose.
Yeah, and you can't do one section, because if you do one section, it might take out everything. Because there might be a critical line going through there that
they just don't know.
Yeah,
it'd almost be worth like laying over a little bit more planned and sophisticated system, and then bringing the other one down once it takes over.
Yeah, but again, who's going to pay for that?
Yeah,
So that's. Okay. So how are the images made? A couple of different satellites up there. I think that the project is only using one of the satellites, but
SDO, right?
Yeah,
that's what it sounded like.
So now here, this worried me when I went to it, even though it said 78%. When I went to classify, I didn't do. Okay, half of the time I click on classify because there are two data sets. If you randomly get the wrong data set,
it's done.
It's done, yeah, and you can't go on.
Oh,
so
it almost, can you refresh to try and get back to the right one?
Yeah, I go back a page and okay, so good.
That's interesting. It almost It needs to be in 2 different segments, like some of the other ones have done. With
Yeah,
different segments. Okay.
That would have been good. That would have been good. Okay, so welcome to the and since I am doing this live, these are not really big on my screen, so I'll read these off.
It's the typical tutorial, though, right?
Yeah, typical.
Oh,
welcome. What's that?
Cliff says our fridge is a gas one since we are off grid.
Oh,
I didn't realize you were off grid, Cliff.
Yeah.
Okay, interesting.
Gas would be good. California's trying to get rid of natural gas because, of course, it's too efficient.
Right.
And it doesn't lead directly to going to electrical.
Right, exactly.
Okay. Yes, and here's where they explain we have split this project into 2 workflows. Yes, they did.
But it's a crapshoot which one you get.
Yes. So if you see that the workflow is completed, go back out, come back in.
Oh my goodness.
Yeah. Yeah, that's lovely, isn't it?
Yeah, fun. Okay.
Okay. Yeah.
You know, it comes with entertainment, this one.
Yeah. So the first workflow was, is it a jet or not?
Okay.
That one's done.
Oh, I see.
So now,
so just dividing between them.
Right. So now it's spotting when the jet begins and when it ends.
Okay.
And there's 12 frames here, and you pick the frame or it began or ended.
Oh, I see. It looks like it was there the whole time to me.
Yeah.
In this particular video.
In this video, yes.
Oh, Cliff says he runs a generator for power.
Yeah. Yeah. But and they say specifically in here, if there's no jet, you just mark no. If there is a jet, you say yes. Then you go and you mark the frame where it first begins, and you mark the spot where it begins. And if it's already there when the movie starts, you just mark the first frame.
So it sounds like you can step through these specific
you
frames one by one to kind of
And so this is so you go for the base of the jet where it looks like the jet's coming out. And so you mark where it begins.
This is a separate task. So there's 2 different things.
There's 3 things that you're doing.
Oh, 3 things you're doing in this? Okay.
Yeah, you mark the frame that it begins, even if it's the first frame.
Okay. The first, which one of 12?
Yeah. Okay. The frame that it ends.
Oh, I
which
see.
Means,
ends,
which could be the last frame. And the frame where it's the biggest.
Oh, interesting.
Because a lot of these jets last more than 12 frames. Okay. So they just want to, and they're going to, their computer algorithm knows where things are. So if it's like a 3 movie set sequence, they want to know when it begins, that it's going through, and when it ends.
Do they tell you how long these, the 12 are? How long total the 12?
Well, they said that they take them 12 seconds apart.
Oh, it's okay.
So 144 seconds, about 2 minutes.
Oh, I see. And we have another comment. Cliff says these flares are millions of miles long as well.
Oh, yeah.
Oh, okay.
Yeah. I mean, every once in a while you see a yellow circle there.
Hang on. Let me get back to. Yeah. Here we go.
That yellow circle, probably about the size of the Earth. I'm not positive, but
oh, wow.
that'd be my guess.
Okay.
So finally choose which it is at its maximum. So that's.
Oh, so you pick the first one, the beginning of it, and you pick the end of it, and then the maximum.
Yes.
Okay, I thought you were picking like the boxing it or something too. No.
No, that was.
Oh, okay.
And at the very end, you do box it.
Oh, you do. So it's sort of 4 things.
Yeah. So here is this image, and then we hit play, and if you notice,
and it looks like it's incrementing through each single.
Yeah, and if you notice, the flare is going throughout the thing.
Right.
So
it's there the entire time.
There is a jet, so I'm going to say yes. And a lot of the times when I was practicing this, only a third of these actually had a jet in them.
Oh, interesting.
So we got lucky the first time. Hit next. And now, base of the jet in the first frame. When the jet appears. But it's here in the beginning, so we're going to mark the base of the jet. and about right there, I think.
Hmm.
I mean, they want to know if there's more than one jet, but I can't see this as more than one jet, but looks like the majority of the activity is right there.
Okay.
So then I go
Cliff
base of the jet.
says that would engulf the Earth.
Yes. Yep. Well, I think if we were that close, it wouldn't matter, Cliff.
we were probably toast before we got to that point.
Yeah. And the jet is still, if we step through these, the jet is still there.
Oh, so you're clicking on the little dots below.
Yeah, I can either run the movie
examine each individual. Yeah. Okay.
Yeah, I can. Oh, and you can change the speed at which it goes too.
Oh, nice. Oh, that's kind of neat.
Yeah. And then
I wonder what the actual speed of them. I suppose it's different for different ones.
Yeah. So it goes to the end. So I'm just gonna mark it there. And now the fun part is, where is it the biggest? Because here it's getting bigger, 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 because it does decrease a little bit toward the end. I'm gonna.
Seems a bit subjective.
Yeah, this one is getting wider, but not more energetic necessarily. If you notice, it's not really growing there.
Yeah.
It
did lose some of its brightness, though.
Yeah.
But maybe that's not a factor in this particular task.
So I'm going to say right there.
All right.
And then, oh, that's right. I need to click that, and then I'll. Oops. Hang on.
It's a box, right?
No, I have to.
Oh.
Oh,
It
box
looks like
it.
a box.
Yes, I box it. Okay.
Yeah, it's click and drag. There you go.
Yep. And I can grab the ends.
Oh, you can adjust it some? Oh, that's cool.
Yeah.
I don't remember that from other ones, from other tasks on here.
And you can grab the end and, oh, no. Somehow, oh, here.
Ah.
You can angle it.
Huh. That's pretty cool.
So
I don't remember any of the other projects having that kind of thing available. Yep. Do you?
Yeah, I don't remember.
Yeah.
Okay, so is there a second jet? No.
Not really, no.
So we're gonna hit done on this.
No, that's it looks like a pretty decent task. It's not too simple. It's not too hard. It's something you can really sink your teeth into and enjoy.
Yeah, and so here's one that's
weird looking.
Yeah. Well, they don't all go out straight out. But if
I don't even see a jet there, do you?
Well, look at this right here. Let's play this again. See, you can see material flowing down here.
Huh. Okay.
Little flares of it in there.
Okay.
So, but there's no arc to it. You can see this has an arc right here.
Okay.
But this doesn't have an arc. So we'd do essentially the same thing there. Now, I also wanted to show the field guide here.
Right. That's always useful.
This is...
And informative.
Yeah. This field guide is more for, is it a jet or not a jet? Which is the workflow that's done.
Oh, I see.
But if you want to look at different types of things that are there, coronal jets, coronal jet widening, this has all of the things. This was very interesting to me, and I read I looked at all of this before I found out that the other workflow was done. So.
No, still.
Yep. But still loops.
Scott says, this looks fun compared to counting rocks on Bennu. Took me over an hour to do one photo. I heard about the rocks.
Yeah. Hey, you'll be glad to know that there's a Zooniverse that's counting craters on an asteroid.
Wait. What?
Yeah.
Okay.
One of the new ones came out. I saw it about the same time I saw this one. It's just this one deals with stars. So
if you're ready to go again, Scott, there you go.
You can count craters. Yeah. So this,
But you really do contribute to science when you do these things.
Yeah.
As of course, Bennu was a great example. I mean, a lot of really great stuff came out of that project, right?
I really don't know what counting rocks actually does for science for
Well,
Bennu.
I think part of it was finding a landing site, right? Wasn't that part of?
I don't
Scott,
know.
tell us. Tell
Yeah.
us. I mean, I'm sure since you were so involved with it, you know oodles more than we do.
Yeah, I mean, it just sounds to me like one of them scientists got OCD and is both OCD and lazy and said, "Oh, we need to count all of these. Here, give it
Crowdsource.
crowdsource." Yes.
Okay. Well, you know, it's a solution. What else you got for us, Jeff?
Just this one, not a jet here. It's just an interesting
because it comes
image.
back.
Yeah. And they called this a still loop.
Okay.
Basically, this is a magnetic field that's running outside the surface and isn't actually moving, at least in the time frame that they've got here. So you've just got stuff moving through it.
Huh.
Kind of like a...
Because, I mean, a still picture is going to look still.
Right. No, but...
Isn't that interesting?
But what they say is that, you know, they have both ends footprints anchored in the sun's surface and are not considered as jets. And they basically, it's just a loop. It doesn't last forever, but for 12 frames, you know, it can look relatively static.
So you could get some of these loops in these little task images. Okay.
Right. Well, theoretically, they've been...
Oh, they sorted it.
That's been sorted already.
Right.
And then, you know...
Oh, Scott comes back with, well, you would hope to find a nice flat spot without rocks for a landing site, but mine looked like a rocky quarry. See, yeah, I thought that was for landing.
Right.
Thank
yeah.
you, Scott.
However, I mean, okay, why are they counting the rocks? I mean, I would think that there's a simple nope button.
So there's a famous song by the Beatles. Not that I know how many rocks. Phil Bennett. Sorry. If you like music, you know what I'm talking about.
Yeah, I'm just thinking that they could have done that a whole lot faster with just image. Nope.
Nothing flat there.
Yeah.
Next.
Yeah.
Well, who knows? Maybe the counting of the rocks, and I don't know if there were classifications of the rocks. Scott, help us out. Someday down the line, that will be useful information.
Mm-hmm.
All right, you ready, Beck?
I think we're pretty well done here.
Oh,
I mean, I can show more of the active. This is an active region here.
Oh, neat.
No jet here. Just interesting feature. If you start from the beginning, it's just as it looks like loops there. Now, some of these jets are looking at the surface, so these were hard to spot for.
Yeah, it looks like
people.
It's like a straight down image instead of something on the limb.
Yeah, they were hard to spot. I haven't seen any of them in any of my testing on what I was doing. So they might have filtered those out of this test because we're trying to find when it begins, when it ends, and the longest. Plus, if it was coming towards you, you wouldn't really be able to tell when it's the longest. So, like I said, there's a lot of interesting stuff here if you want to get into the definitions. And again, there's the talk where they where you can have discussions about various things.
Yeah, it's a regular chat board, right?
Yeah, and this is typical Zooniverse stuff.
Cool.
These are collections. These are ones that other people found interesting. So if you want to look at some interesting stuff, here's what other people found interesting.
Yeah, I mean, I really like the aspect of it's not just for their benefit. It's this is stuff you can learn too. That's always cool to me.
Yeah. I
can learn some cool stuff as well as help this nice project.
Recent classifications. This is one that I did. So this is slightly
you just
different.
Did that.
Yeah. So recents is the stuff that
your
you did.
recent classifications. Oh, that's pretty cool.
Now, this probably will not survive me going out of the page and coming in because I didn't sign in.
Okay.
And they do definitely want you to sign in.
Yeah, they definitely have on the.
Yeah.
I forget what the phrase. What does the phrase say? You should sign in or something.
Yeah. In fact, when I was testing it, it was actually showing up right here. You should sign in.
Yeah. Which is fine.
Yep.
Is fine.
Yeah.
Cool.
So
you can help and be recognized for it,
Yep.
like by signing in, or you can help and
Okay.
just do a few and move on. Cool. All right. So if you have any questions, let us know. And now I'm going to talk about some stellar events this week because you're done, right?
Yeah. And
Okay.
hey, the internet lasted through when
So far.
was sharing my screen, so that's good.
So far, yeah.
We don't have to. If we have to switch to the phone, the presentation's done.
Yeah. It's good. It's nice to have a good block of information. All right, so when we're talking about stellar events this week, we're talking about June 24th through July 1st. It's already going to be July soon. Can you believe it? I do want to remind you that the planets are in the early morning, and from my handy dandy Farmer's Almanac, and we have a nice picture. Would you mind sharing that screen? From the 16th until month's end, that's from the introduction of the Farmer's Almanac. All of the planets form a line like a string of pearls. And there's a nice picture from Cliff. He had that on Facebook. I thought I would share that with you. Moreover, they appear in their true order from the sun. From lower left to upper right, some 45 minutes before sunrise, look for Mercury, Venus, Mars, Jupiter, and Saturn. The crescent moon visits each. Look for the moon below Saturn on the 18th, Jupiter on the 21st, to the right of Mars on the 22nd, above Venus on the 26th. And that's actually coming. And above Mercury on the 27th. Yeah, Cliff, what you got?
And there's more energy in a flare than we could use in 1,000 years.
Oh.
We would never need to use coal, etc., ever again.
How do you capture that? That's the question.
It's just like there's a lot of electricity in a lightning strike, too. You just, hear catch.
So let's see. I have a link for, I think it's Globe at Night. Go ahead, and you can come back to us, too.
Oh, okay. Yeah.
So the current Globe at Night project is finishing up. Remember, you can go out, take pictures of the target, compare that to the charts on their website, and report your findings. This project went from June 19th to June 28th. That's just a few more days. In the Northern Hemisphere, you're looking for Hercules. In the Southern Hemisphere, you're looking for Scorpius. I'm going to go back to us. June 25th and 26th is Field Day. This is a ham radio operator event. And I am reading from, we can go back to the thing now. Let me get to, hold on. Let me get to, where is it? It's actually the next.
Field Day.
Here we go. Thank you. Yes, Field Day. ARRL Field Day is the most popular on-the-air event held annually in the U.S. and Canada. On the fourth weekend of June, more than 35,000 radio amateurs gather with their clubs, groups, or simply with friends to operate from remote locations. And I have a link for that, too.
Oh, yep. And Cliff says, we can only dream of such power.
Oh, yeah. That would solve a lot of problems.
Yeah. Of course, you put a Dyson swarm around the sun and you get all the juice.
Yeah, maybe.
You use about 5 or 6 solar systems worth of mass to do it, but hey.
All right, so there is a website to find a location near you doing a field day with the ham radio operators. And this comes around every single year. I don't know what they did for the various shutdowns, but yeah, there it is. Yeah, see Field Day Locator. On the 26th, Venus and the moon are in conjunction. You can go back to us. Then on the 27th, I wanted to alert you to a launch. I got a link for that one. And and a picture. Jeff sent me a link today from work. Capstone.
Oh, did you want to get to it?
Yeah.
I can add it, but
I see.
Not on it.
Yes. Let's coordinate our effort here. There it is. Capstone is targeted to launch no earlier than Monday, June 27th, aboard a Rocket Lab Electron rocket from the company's Launch Complex 1 in Mahia, New Zealand. The instantaneous launch opportunity, that's like, it's going to go now or it's not.
Yep.
is at 6 a.m. Eastern. That's in the United States Eastern. It's also 10. That must be 10 a.m. UTC, right?
Yep. And,
Live.
and since that's a long, nasty link, I just posted it.
Awesome. Thank you so much. Let's see. Live coverage will begin at 5 a.m. on NASA television, the agency's website, and the NASA app. June 28th is the new moon. On June 29th, it's the weekly space hangout, and I am actually going to be on that show as a journalist. We're going to focus. The guest is going to is talking about focusing James Webb Space Telescope with it's Lee Feinberg. He's the optical telescope manager. And we're back to July 1st, the Friday night show, and I'm going to bring you my book, and I'm going to talk about a chapter in it because my goal is to finish the 2 sequels, the second book and the third book, and talk a little bit about how I've built in a way for people to understand that there are books for each, that kind of thing. Anyway, sort of a mindset thing, as well as sharing a pretty cool thing you can do. Anyway, come back next week. You can find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. Yeah, you got a comment for us?
Yep, from Cliff.
Cool.
My friend Sean O'Neill works there in New Zealand.
And we are in communication with him to schedule a show.
Nice. Yep. Okay.
Can't wait. Encourage him to answer, although he's probably pretty busy with this launch.
Yes. Yeah, we might get him. We might start talking to him after the launch, probably. Okay. Ongoing events and activities. Space Prize, at spaceprize.org.
Yeah, I'm not sure if this is done now or not, so I thought we'd talk about it just in case.
Okay. Yeah, it launches June 2022.
That's this month.
Almost was.
Yeah, almost over.
3/4 of the way through it. Space Prize Global is a worldwide contest to promote the advancement of women in STEAM, specifically in aerospace. Open to 15 to 18-year-old women worldwide, the contest features a combination of written, video, and creative submissions. 2 grand prize winners will each receive $250,000 of private astronaut experience.
Unless they already won, I'm not sure.
Yeah.
I'm not sure of the timing on that. I looked at the site. I didn't see anything more specific than June.
Well, it's still June, so we're doing it. I guess next week we won't because it won't be June anymore.
Bypassed, yeah.
Yeah. Well, then we'll know it's passed.
Yeah.
So, with reservations for 2 winners on one of the first Space Perspective flights, the Space Prize Global Challenge will be a worldwide contest to promote the advancement of women in STEAM.
That sounds really cool, doesn't it? I'm going to go to the next one and set this up for right here.
You want it? No?
Yeah.
There we go.
Cool, right here.
Oh, Kennedy Center Visitor Complex Scavenger Hunt.
Yeah, Cliff posted this, and I don't know much about it, but I thought we would talk about this scavenger hunt.
Yeah, because this is the first I've seen it.
Yeah, here, just go ahead and read that part.
Kids of all ages can learn about the different stages of the Artemis program.
I'm hoping I'm one of those kids of all ages, too.
Once the scavenger hunt is complete, explorers can collect a mission success reward.
How cool is that?
Yeah. Okay, what's this one? Oh, the Sci C9.
Well, I think it's science is cool.
Science is cool. How do you get that out of?
Yeah, I don't know.
Science.
Here,
okay.
Just read this part.
Yeah, how does C9 become cool? I don't know. Okay, let's go back to the.
No, just read it. Just read it right here. There's this and there's this.
Virtual Unconference for Cool Teachers.
Yeah, August 5th.
August 5th.
It's like an all-day event, and it's let's see. Yeah, here we go. Here are the times: 9 a.m. to 4 p.m. Pacific time.
Yeah. So, if you all in Australia want to get up really early in the morning, there you go.
And this one's in the fall, so we'll skip that until it's time.
Yeah.
All right, so let's check for comments again. We know you're on delay, so.
Oh, here. Cliff said, I'll show the video as I was seeing myself in
Oh,
California.
what video? I don't know.
Oh, the one where you had the still images going through it, and then he says, I'm
chuffed it. Yeah.
I'm chuffed that you were showing some stuff from my club site.
What this? Where is it? I'm looking, Cliff. Help me, Jeff. Do you know what he's talking about?
Yeah,
Here? Is it here?
our video, the branding video.
Really?
Yeah.
No, not.
Yeah, the one that goes through the various images.
Oh, the book ad. It's right there. It's right there.
Right, this one?
Yeah, you want to see it, Cliff? We can run it for you.
Yeah.
Cool. It's funny. No, not that one. That's not it. Sorry. It's the other one. And we got to remove us. We got to, here, remove and then hit the other one. My friend Tracy makes much better video, Cliff, but there you go. 55 seconds with our friends from the great country of Australia. All right, any more comments? We are checking in for the last time. Yay. I thought you were referring to something on your Facebook page that I flashed as well, Cliff. We really love your participation. Thank you, Cliff, for being here. Thank you, Scott. I think those were our main audience for tonight. We really, really appreciate you here. You just make it so much better. So we're going to wrap it up. If you or someone you know has done something interesting involving space exploration, science, astronomy, we would love to share our live. Join us again next Friday, July the 1st. I'll pick something from my first book and talk about the 2 sequels that I'm writing. Thanks so much. Have a great week, folks. Anything from your side?
Nope. That'd be it.
All righty. Good night.
Good night.